Okay, so we're going to do a quick overview here of sending a parameter from the pod to the ground station, and maybe going back to with a command. We'll see how far we get here. So over here, I just have the ground station cloned from GitHub and all set up already, which is just npm install basically. And we're going to fire it up. Take a couple minutes to assemble everything here. You can see right there it says what port it's listening on, and there it's already doing stuff in the background. Let's see, in a minute here it should tell us the web page is ready. There it is. And there's the ground station, the IP, then the port that, well, localhost, and the port that's on. You can see our Power A is already online, which I actually have a little development board sitting on my desk here, which is running. And we're going to play with that code today. So let's go Power A overview. And you'll see it's sending some data, which is really just nonsense because there's nothing attached. Which is a little interesting to see what it's actually doing. So these are all the parameters that Power Node's sending back. So let's look at what it takes to add something. Well, actually look at the documentation first here a little. So we're in Confluence, you can see where I'm at, our loop, avionics, subsystems, Ethernet, packet types. And these are all the packets that go back and forth from the pod. All sorts of fun stuff. And we can find the BMS system, which we'll be messing with here. Power node. Battery temperature stuff, battery management system, which is actually what we want. And we'll mess with the BMS status packet because we can. And you'll see here, it's just saying, basically the pod will send back any number of different types of packets, and each one's just labeled with an index of some kind. It's a 16-bit value. There's a hexadecimal version of it. And the one we're going to look at is return the BMS status packet. So that's the pod returning data about the BMS to the ground station after being requested to do so either by this individual one, or you can just turn on streaming, which just sends it like 10 times, 100 times a second. I forget what it is, but it's often enough. So let's dive into the code on the Power Node. And here's Code Composer already running. It's more of what it looks like when you first open it. There's the Power Node. It's cloned right off the GitHub page for it. And if you follow the format here, you can kind of figure out where the file is in the project. Let's see if I remember. RM4, nope. No, that's more low-level stuff. We want our loop power core. Here's the high-level systems. BMS battery management system. And we're looking for the one that says Ethernet at the end. A few of these have the Ethernet types. So you notice in the main code here, power core, in the main state machine, when we're running, init state run, this is kind of the loop that it runs every time. Just jumps through all systems doing their processes. And inside one of the processes for each system is sending Ethernet packet if it is time to do so. So we can go this way, Power Node process, or the BMS process, and open that up. That's just a declaration. Actually, that's right. Yeah. Power core, if you were to follow this through, you'd figure out where it sends Ethernet packet in here somewhere. Which you should. There's where it starts Ethernet systems. It might be lower level, but if you were to follow this through, you'd find it somewhere, or it might be in here somewhere. But, don't remember where that is. You have to trace it down, but just say if you open up the Ethernet area, you'll find the transmit function, which is what we want. And you will notice somewhere in here, TX BMS status. If you open that up, you will see there is 3401, which is exactly what we saw in Confluence. 3401. And if you go back here, you will see all the types of data that it's transmitting. So it just basically initializes a packet to send, And then starts adding data based on what type it's currently working with, which in this case, we're going to modify the one for sending to a status packet. And you'll see the packet starts off with some fault flags and then some information about the state machine for the temperature sensors, what state the charger's in, and miscellaneous other parameters that we need to know about that system. Oops, okay. And so what it'll do is it'll transmit this packet over the network. And if we want, we can even pull up Wireshark and take a look. Ideally, we'd set up some intelligent scripts to parse these packets, but we haven't. So it'll be interesting, but not particularly understandable unless you want to sit there and count out bytes. And we'll go over and look at our definitions here. Where's Confluence? And if we go to static IP assignments, we'll see data from the power node should be on. This is power node A, power node B. Port, their UDP packets, port 9110. So let's see what we got. And you'll see a bunch of packets from it, and they're all the same length, so they're all pretty much the same type. And when it starts up, it automatically starts streaming that particular type of packet. If you scroll down to the data, and the screen's a little small, so it's not showing me everything. There's a bunch of bytes. You can tell here, what are we looking for? 3401, and network byte order. So it's a little backwards, but... And if you were to trace down the packet, you would see all the individual parameters just stacked on top of each other here. There's some stuff at the end to finish up the packet, but... yeah. So, Wireshark, good to see if packets are coming across, but we haven't written any intelligent scripts to parse them in there, so... but with our ground station fired up, it ends up here. And it does that by looking through the packet parser file, which if we go back to the, here's the ground station code. Let's see, it's been a while, but source is what is running in the browser. And server is the Node.js server backend that has all the code in the back that processes everything and gets it ready to be served up to the browser. So somewhere in here, not actually in here, but server code, and then we go back to the config. These are some configuration data for the server. Then you can go packet definitions. We'll open that up. We'll see here, it's already up to where I was looking before, power ABMS. Well, and here's all those different types of packets that can be sent from the pod to the ground station. And we just kind of define what's in those packets, and it will dump them in a dictionary for us to query from the front end. So right now, name, power ABMS is the name of the node, parameter prefix. You'll see what that does in a bit. Packet type, there's that 3401 that we're working with. There's a node. So I don't remember what the difference is between these two. I think each type has its own unique name. I don't remember how much that's used, but there it is. DAC. There's two types of packets. There's this streaming packets we're working with now. There's also some data acquisition packets, which we can't parse at the moment, at least with this code. There might be some remnants of that code in there, but I don't think it's fully working right now. But back to the packet we're working with, 3401, and you'll see faults, temp state, and it's listed out exactly what parameter it is, how big it is in the packet, both in a data type, so signed, unsigned, floating, non-floating point, and the byte size. So floating or a 32-bit value has 4 bytes. 8-bit, unsigned 8-bit integer just has 1 byte. If you notice, we'll put these side by side, even though it's not all that legible. A little better. Go back to Code Composer and do the same thing. And you will notice as you scroll up, fault flags, temp sensor state, charger state. You just go down the list and they're all added in there. And they must line up exactly, so otherwise it will just grab random bytes out of that packet and who knows what will come out the other side. So we got two pieces of the chain here. Sends out of here, goes over the network, gets parsed through this database, or this, lookup table, database, whatever you want to call it. And then, let's take a closer look at one of them. So average temperature. It's over to average temp. You'll notice this parameter prefix, power A, BMS, average temp. And then let's jump over to the browser side of our ground station. Source, let's check out the app page. So this is kind of the, sets up the application. So right now we're looking at the power A overview, which if you'll notice is the component power overview, and we're sending a parameter of A. So the power overview has the same source code for both nodes, but you send the parameter for which one we actually want to look at. So component is defined up here at the top of the file. What we look for, power overview is in here somewhere. Power overview is in the components, power overview. Let's go grab that file. Components, power overview. Cool. So this is a page that's actually rendering that page, the ground section we're looking at. And what we can do is grab the name from the packet definition. So power A, BMS, average temp. If you'll notice in here, you'll see one. Where is it? Power. And then this is filled in based on the parameter. BMS, average temp, which is not all that legible on this screen, but power, parameter, BMS, average temp. And in this case, this is using kind of a fancy way of rendering a bunch of parameters at once. Scroll down here. There's a few components that make this a little easier. And this whole page, you can copy and paste if we need to make another page and strip it down to a template type thing. And some of the other pages are a little simpler to parse. This one has a bunch of tables and buttons and stuff. You'll see all this HTML. Generic parameter labels. You can always throw one of these in. You send it the manager for everything, and then you just specify your parameter. That's a quick way of throwing up a label on a page. But in this case, we did a bunch, so we made it a little more intelligent and used some JavaScript. Which actually, as you tell, this is a JavaScript file. It's all based on the React framework. So you have to look that up and do some research, but it's a little easier to understand if you kind of tweak what's existing. Eventually, you'll kind of understand how it works. It's kind of an interesting little system. But so essentially, all these labels, just grab those values from the dictionary, and the backend kind of handles the whole intermediate process of just has this massive table, and each page basically just says, hey, I need these 10 parameters, and the backend will just sit there and send it those parameters as fast as it can. Not technically as fast as it can, but fast as we care to see them. And that's that. So let's look at adding a parameter just for the heck of it. Let's add something between average temp and highest temp sensor. Go copy and paste. Average temp. Let's just transmit some number, and I'm probably typing weird. Float 32, that's fine. I have to remember what the type is for floats in this thing. Let's see. Float 32. And we're just going to send it some random value. Cool. So we're going to see that on the ground station. Yay. It's between average temp and highest temp sensor. It is a float 32. So let's get this building. Build project. In theory, you can do all this in the emulator when Lachlan gets that all coded up. And then you could actually do this in Visual Studio. And it'd be the same code, but run on your computer and just loop back instead of actually working with hardware. You can simulate input and all that fun stuff. So it's built. Let's send it off to my little dev kit. And this is going to take a few minutes, so we'll let it program while we finish up the ground station. Packet definitions. Where did I put that? Oh, error connecting. I don't have USB cable attached. Give that a second. Should pick it up. Let's try again. There it goes. Okay. Let's go back to the edit page. Where did I put that? After average temp. So we're going to take after average temp and duplicate it. Oh, and they put some fancy syntax checkers, so you need to use spaces instead of tabs. It's kind of annoying, actually, but someone wanted to do that, so good for them. Means we'll be consistent. Let's call it random number. And you notice this all filled in already because it's the same thing, float 32, 4 bytes. Cool. Packet definition, save. And when you save a packet definition, the server will not reload. Normally when you modify code, it will reload the whole thing for you, but this is a config file, so it doesn't auto-kick that off. So we'll go back to our PowerNode overview, and let's just add it, let's say at the top here. Label number power A BMS. What do we call that thing? Random number. This will be power A BMS space random number. And paste. And we save this. We should see it kick off a rebuild here in the background. Yeah, Webpack rebuilding. Doesn't like me. Unexpected tabs. Yeah, it doesn't like tabs. It's kind of annoying. Let me see what I can do about that. See if that does it. Hey, we just have warnings. Someone should clean up these warnings, but whatever. Yeah, you can see all the style things it's trying to enforce and be grumpy about. Back over to Code Composer, I was debugging, it loaded, let's play the file. PowerNode is taking a while to boot at the moment because it doesn't have devices plugged in and it's waiting to find them, which it never will at this point. Oh, did this stop capturing? I'm going to be annoyed. Okay. So go back to our ground station, you'll see the power status is offline, which is fine. It's going to take a minute or two to come online. If we hit refresh, though, we should see our random number field, which has no data yet. So in a minute or two here, this should go from offline to online, and we'll see our random number pop up if I did everything right. Maybe. Let's... Online. Uh-oh, no number. And we're counting, so I missed something here. Let's see what I missed. I did this yesterday too and missed something, so Ethernet. Let's see. Random number. Average temp. Random number. Average temp. Random number. Highest temp sensor. Let's make sure it's getting there. Yeah, it hits the breakpoint. It may not have reloaded my config file. Let's see if that was a problem. Still loading, still loading. Done loading. There it is. I guess you have to fully kill it to reload that file. Good to know. And you'll see it's counting voltage updates. Don't know why this says question mark though. It could just be that that particular system hasn't hit its breakpoint or its Ethernet transmit yet. So cool. There it is. There's getting data from the pod to the ground station, and that should be enough. You can dig through all those functions that we did and trace them back either direction if you want to know the guts in the middle, but basically there's a function that sits there and reads all the packets and parses them according to the definitions that we built up, adds them to a big dictionary, and then the ground station front end just sends a request over socket.io of what parameters it would like to display at the moment. And actually that needs a little help at the moment, but it does work pretty well. Let's look at some of these other commands, how we get commands from the pod, ground station to the pod. which is fairly simple. Each button triggers a command from the front end to the back end, and the back end receives that and then pushes it to the controller that we built for the pod in the back end, and the back end then pushes that back to the code in the pod. So we should actually be able to hit a full process here and watch a button trigger something on the main code composer. So let's just trace start charging for that command. Start charging. And let's pull up the code. Review. Let's find that button in here. Start. Where render. Okay, button. Here's our button. On click this dot start charge. Find that function. So it's going to emit to the back end a power a start charging event. Now I get to remember where that is in the back end. Let's go back and look through it. Server. Where is that? Oh, one thing I did not mention on transmitting data, so take a quick break and get back to what we were up to in a minute. But if you look through this one, test generator, that's cool. The main code in here is, I think it's index. It's been a while since I played with this. If you look at index, you can see all the things that the server does. Down at the bottom, test data generator. It's not actually just for the accelerometer anymore. It's kind of cool. You can look at all these payloads in the file somewhere. I must have done this. Sorry. All these different payloads, and the JavaScript will actually generate the packet as well. And what that lets you do is if Lachlan's posted some change or you're browsing to see, and it's like, oh, he added this, you can create all your fields, go into the payload file, and create a fake data packet without using any of the other C code. And it'll just transmit like 1, 2, 3, 4, 5, 6, 7, 8, just count or something, so you can at least make sure that you're checking for basic syntax errors and making sure data can at least get through from one end to the other before trying it with the pod or the emulator. And if you go to these payloads files somewhere, data generators, there's a few versions of this. Let's see where we're at. Here we are. Test payloads, there's accelerometer packets, optodistance sensor packet types. You can look through the syntax and figure it out, but it's just basically building up a packet that will send some fake data. Where is it? There's a BMS streaming packet, so if we wanted to, we could add another line here for that random number. And then go back to the app. Index, and enable a generator, which we wouldn't want to do if we were actually connected to the pod. So these all need to get disabled for production. If we were fancy, we'd have some startup scripts that turn this on and off, or somewhere in the code or in the GUI to do that, but we don't. So right now it's just commenting lines on and out. But it's a good basic troubleshooting. If Login says, I posted this and it's on the C file somewhere, you can just come and uncomment, add it to all the GUI stuff, and then test it real quick, and then you have a fairly good idea that it should work with the actual pod. But getting back to sending buttons. So we were looking at the start charging button, and we found the start charging function on the front end, and we're trying to figure out where it comes in the back end. And it's been a little while, so I need to remember where this is. And actually, if you ever forget, this index file is a good place to start looking for things. Here it is, WebSockets handles commands from the client, i.e. the browser, to send to the pod, and they're all in the WebSocket commands.js. Listen for UDP packets. Oh, that was something old. And you'll see that command that we saw in the JavaScript browser end. What was it? Power A, start charging. There it is, Power A, start charging. So this is receiving from the browser to the server backend, and then pod commands is another file where we just have all the low-level definition of what these commands are to the pod. And you'll say Power A, start charging. This kind of intermediate file, whether it's necessary is up for debate a little. If we had more sophisticated commands, it would make a little more sense. In this case, it feels like there's kind of an extra step at the moment, but that's how structure goes sometimes. And then we're going to the pod commands. And we're going to look at the start charging command here. Where is it? I suppose I could search, but how do I start charging? You'll notice there's the function udp.transmit transmit pod command. This is the node name, which it uses. We're using names instead of IPs, so somewhere there's a config file with all the IPs listed, so you can change that in one spot. The command name, or command type we're sending, and then some parameters, fields 1 through 4. And if that all looks strange, and where did I come up with that? That is all in the code here. Packet types, here we go. And we can go down to our power node. Power node, packet types. We're looking at the charging command, which is 3020, type 3020, right there. You will see in here, packet type 3020, and you'll see these parameters. He calls them blocks 0 through 3. So it's just 4 parameters that you have to send it. And it lists what they are. This is a key, so we just send some random number and verify we get that random number on the other side. And that's just a safety check to make sure that it is in fact the command we wanted, and not someone just typed 3020 on some other command and we randomly did it. So it's just kind of an extra safety check. And just whether we want to start or disable charging. I think this comment is off somewhere, but and if you were to send this command, it would start charging. So let's see where this goes on the other side. And this is connected to the processor on my desk, if you did not figure that out already, which is why I can stop through and see what it's doing. So here's a fun part of remembering where the charging commands go. It would be under the charging subsystem. Charger, Ethernet. Don't know why it has those symbols. Don't know. And you'll see here Ethernet transmit, which is not what we want. Let's see. Somewhere in here is the command to charge. This is the part I did not rehearse, so you're having fun watching me figure out where things are in code again. It's been a little while, but we can trace this the other way as well. Go back to the main processing loop, and it's all in here somewhere. BMS task. I think it's in the main Ethernet. It's probably in our networking here, actually. RX. Yep. Safe UDP RX. Then we'll scroll down, and somewhere in here, charger control. And you can see where it's checking for that magic number, and then it just acts on it. And if we put a breakpoint here, when the code hits this point, it should pause for us. And let's see if I can get these side by side and show that off. Should be able to do this in the emulator in Visual Studio, something very similar to this. Of course, Code Composer is what I'm using to interact with the actual hardware, but Visual Studio should do most of the similar stuff. So when it starts charging, it should breakpoint if it likes me today. There it goes. It has hit the top of the function. I don't know why it stopped there. And it's loading a bunch of information in the background of where it stopped, why it stopped, and what variables are currently floating around, which is amazing on this scrunched view of everything. And if we hit play, it should jump down to that actual point that we set. There it is. I think I just accidentally put a breakpoint at the top when I was clicking around. And you'll see it's got the command. If you hover over it, there's a way to get that to show hex. Right now it's a decimal representation of that variable. But if you were to figure out how to get Code Composer to show you hex in that pop-up, it would line up with that number. You can see we hit start charging, so that second parameter should be a 1. U32, the second parameter starts at 0. You can see actually you show all of them. There's a magic value. There's the 1. If we were to stop charging, that would be a 0, which we can demonstrate as well. Yay, found the magic block. 0 this time. and it just kicks off whatever else is in code. So all the commands are received in this file, the Ethernet module, networking, the RX. To transmit, all the individual functions manage their own transmit. So, because there's nowhere to delegate the received packet until it's processed it. So it can't magically send them to the individual subsystems. So I think that is that. I showed the emulator too, but I don't think it's working at the moment. Lachlan's been cleaning that up the past few weeks and should have it pushed any time here, which will be great. Then you won't need a fancy dev kit, which I don't even think you can get the particular one I'm using anymore. Kind of bummer, but we'll look at the RM57s. So hopefully I didn't go too fast and it all made sense. Yeah, post any questions in channel, and that's that.